A successful validator deposit is perhaps the beginning of a joyful journey of an Ethereum validator online. If you are interested in having a sneak peek of proposed changes to protocol with respect to validator deposit, stay with us. Welcome to PEEPanEIP episode 112. I'm Pooja Ranjan and super excited to host our special guest to talk about upcoming protocol changes. EIP-6110 Supply Validated Deposit on the Chain is a standard track core EIP, originally proposed in December 2022, has been co-authored by Ethereum researchers Mikhail Kalinin, Danny Ryan, and Peter Davis. To provide an overview of this draft proposal, we are joined by Kevin Bogner, Navie Chan, and one of the co-authors, Mikhail Kalinin. We are also joined by the co-author, Peter Davis. Welcome all.
Thanks, Pooja. So I guess we can start by introducing ourselves. Yep. Okay, so my name is Mikhail. I'm from Consensus R&D, lead of a TXRX team. We're working on the Ethereum protocol and the Ethereum protocol research space. I joined Ethereum back in 2015 in its early days, and my most significant contribution to the Ethereum by this time was participating in the merge on other brilliant developers and researchers. And yeah, what was interesting and really related to the context of our talk today, because this 6110 proposal is a kind of follow-up to the merge. So that's from me.
So my name is Kevin. I'm based in Stuttgart, Germany. I started off in core development about, I think it's now 8 months ago, with a program called Ethereum Protocol Fellowship. And the program's goal is to onboard people to Ethereum core development. And the whole program lasted for 6 months. And it was the third iteration of the program. And during this time, I've worked on a project with Navie, with NC, called Consensus Client Reward API. So you are now able to easily access reward data for running a Ethereum validator. And during this program, I met Mikhail at an AMA. Yeah.
All right. Yeah. So I will continue. So my name is NC or Navie. So yeah, same with Kevin. Like we were in the same cohort in the Ethereum protocol fellowship. I actually learned about this fellowship on Reddit. It was like one day I just browsed Reddit and it says like, oh, this is permissionless. So I just joined and start contributing. Yeah. So currently I'm working on Ethereum as like a side job, like on a weekend thing. So yeah, it has like, lasted 6 months so far. Maybe like my main job. So I came from like a computer science background. I graduated from University of Toronto and, I've been working for 5 years, mostly in the financial institution. So this is like, completely new to me.
Hello, I'm Peter Davies. I have a similar background to Navie, although I did maths at university. I then joined what's now the Ethereum Protocol Fellowship, but was called something else then. I've been working on specifying the execution layer for the last almost 2 years at this point. And I did some work on this EIP, making some of the suggestions for the design and also doing some denial of service analysis.
Awesome. I find it inspiring. Hopefully, it will help and inspire someone listening to this conversation today. And we get some more contributors to Ethereum ecosystem. Let's continue with today's talk. So without further ado, let's peep in.
Yeah, so let's get to the proposal. So the agenda is quite straightforward for today. We'll come through the deposit reform, through its benefits, cover security analysis a bit. And guys, we'll talk about the details of execution and consensus layer implementations, and we'll touch base on the status of the prototype and share some challenges we found during working on the prototype. So basically, this is the header from the EIP, and it is basically proposes the new way to deliver deposits from the execution layer to the consensus layer as an alternative to what we have today. And to start describing those changes that are in this proposal, like to start from the existing machinery, which is called Eth1 data pool, and which works on the mainnet today, and which allows the consensus layer to basically pull deposits, to fetch deposits from the execution layer, and then process them to include new validators or top up already existing ones. So what we see here is basically our blockchain that everyone is familiar with. We have beacon blocks, And every block, every beacon block contains the execution payload with transactions and all other chain data. Yeah, beacon blocks also carry deposits, which is the subject of our talk today. So every 2048 slots, there is the ETH1 voting period that happens. And this ETH1, during this ETH1 voting period, proposers vote on the view of ETH1 data. You can see it here. It's basically 3 fields. This on the view of ETH1 data at some follow distance. So the follow distance is also defined as 2048 blocks. This large number has been picked to make this rework resilient, and the entire ETH1 data pool operates on the assumption that should there be any reorg in the network, it will not be the size of the rework. It will not last for more than 2048 blocks, which is quite reasonable. We are not supposed to see such reorgs on the mainnet. So these two parameters basically is a factor of a big delay between the submitting the deposit transaction, like here, and included this transaction into the beacon block to be processed by consensus layer. ETH1 voting period can last less than 2048 slots. Basically, we need for more than a half of proposers from this period to agree upon a certain sample of ETH1 data. ETH1 data includes the root of deposit tree, the deposit count, and the block hash at this follow distance, as mentioned before. So in the best case, the delay between submitting the transaction and included this transaction and processing of this transaction by the consensus layer will be around 12 hours. So every deposit is accompanied with a proof, which is a Merkle proof linked to this deposit root of ETH1 data. And this is one of the requirements of one of the validity conditions of deposits on the consensus layer as of today. Also, if we take a look at the Ethereum client perspective, for this machinery to work, the consensus layer client has to support and maintain an ETH1 data fetcher component, which is quite a sophisticated component because it maintains a cache of all deposits and it constantly submits requests to the execution layer, to the JSON RPC API, to track the head of the chain, to fetch transaction logs where the deposit data of a deposit contract where the deposit data are actually being contained. And all this requires this machinery to get bootstrapped, requires the execution layer side to be fully synced. It also requires consensus layer side to obtain the entire deposit tree to start actually include deposits into blocks. So that sort of complexity on the chain side and inside of a client was inevitable when we had two chains in the past. One was the proof of stake beacon chain. The other one was the proof of work Ethereum mainnet. And this is basically the bridge mechanism between the two to induce deposit data to the consensus layer client. But today, after the merge has happened and we have only one chain, we can simplify this mechanism a lot. And this is actually what is proposed by EIP-6110. So the essence of this proposal is the on-chain deposits approach. So how does it work? Basically, execution layer client, when building a block, it scans for the transaction list that is prepared to be included into this block, and looks for deposit transactions in it. Then it gets the logs emitted by the deposit contract inside of those deposit transactions, parses deposit data out of it, and includes this deposit data as a separate list into the same block. So after that, this block is submitted to the network, and every client that receiving this block passes the execution payload to the execution layer client, and the execution layer client, as part of its block validations, matches this data. So the execution layer client will ensure that the list of this data is corresponding to the deposit transactions that are included in this block. If it's not corresponding, if there is a mismatch between these two lists, the block is deemed invalid. After that, consensus layer client can securely read this deposit data and process them. So we don't need any proof here. So all the proof is happening on the execution layer side. And likewise, we don't need the ETH1 data fetcher anymore because these data are naturally included on-chain and are accessible by the consensus layer client. Okay, so let's summarize the benefits of this proposal. First of all, there is instant deposit inclusion versus waiting for about 12 hours in case of one data pool. This proposal allows us to get rid of the client complexity, which is coming from necessity to have this ETH1 data fetcher component, which already has been proven to be brittle. We had some problems regarding that in the past on the mainnet. So some block proposals were failing for quite short period of time, but it still was quite annoying. So, and this component is proven to be brittle, and we don't know what can happen next. So there is the on-chain deposits does not depend on historical deposit data. And this is especially important in the context of historical data expiry proposals like 4.4s. If a portion of execution blocks can be expired and not contained in a node anymore, in data that node has access to, we would need to obtain a deposit contract snapshots. There is a proposal for these snapshots and for format and how they can be maintained. So the on-chain deposits does not need this dependency as well. And last but not least, this on-chain deposits proposal comes with more security than the existing mechanism, because as I mentioned, ETH1 data voting finishes at the moment where more than a half of proposers agrees on some ETH1 data. It means that if there is a slightly less than a half of a total stake is malicious, those malicious validators has a non-trivial probability of coming to agreement and forcing everyone to come to agreement on some arbitrary ETH1 data, which would allow them to induce more and more deposits. And though the number of deposits will be constrained by the existing constants we have in the protocol, but anyway, then if they come to agreement on ETH1 data that does not exist, they can increase their portion of stake, like by ETH taken out of thin air. So there is an issue about that. And while on-chain deposits comes with basically the same security thresholds as the core protocol, because they are secured by the core protocol, actually. A bit of data complexity and DOS vectors analysis. The historical data growth is negligible. 60 megabyte per year is what we have at the current pace, and which is really nothing with respect to other data, blockchain data that we have to deal with. What is non-negligible is that clever actor can pack up to 1,200 deposits in a 30 million gas block, the size of a block that we have today on the mainnet. And it means that every deposit has a signature that has to be verified during processing this deposit, and having 1,200 deposits in the block would mean that the block validation can be delayed by more than a second by the signature verification. Fortunately, there is the minimal deposit amount that we have in the deposit contract, which is 1 ETH, and this minimal deposit amount gives us quite good protection from this kind of DOS vectors. So someone will have to obtain 1,200 ETH to employ this attack, and this ETH will not be burned, it will be deposited, and later on it can be withdrawn and so forth. But anyway, it does not seem to be a viable DOS attack long term. So one can do this, but it will just slow down one block. It doesn't seem like a big problem. First, there will be a transition period. So we have two mechanisms. We are switching from one mechanism to the other. So how does it look like after 6110 is activated? After the activation, and there will be a gap because of this follow distance and voting period time, and the new deposits that will be included on chain will start to be processed instantly. So this ETH1 data pool and on-chain deposits, they will work together for some period of time. And the goal of ETH1 data pool in this context will be just to bridge this gap, which should last for 15 hours, hopefully, in the worst case. And once we see the evidence that there is a deposit in the beacon block submitted via ETH1 data pool machinery with an index that is less by 1 than the first on-chain deposit index, then we can say that the transition period is over. No no more beacon block deposits are allowed since that time. And after that happens, clients can remove ETH1 data pool machinery in uncoordinated fashion because the protocol will not depend anymore on that. For this purpose, we add one variable which will hold this first deposit on-chain deposit index in the beacon state. So that's about the transition. Now I'm going over to Navie.
All right. Yes, so I will cover the changes on the execution layer side. Yeah, so here is a list of, major changes on the execution client. Yeah, so first of all, obviously we need to define the deposit structure, like what kind of fields there is in the execution client. It's mostly for, the engine API, request parameters and the response, and also for the RLP, the input and the output. And then on the execution payload, it will be very similar to current execution payload, except we add the deposits in there. And then on the block header, we have deposits routes as a new field. And then in the block body, we have the deposits. And then for the block creator, obviously, now it creates blocks based on new block header and block body, but also it needs to extract and decode deposits from the transaction receipts. And then for the block validation, there needs to be a new mechanic to validate deposits. In the Genesis config, there will be extra parameters, which is called the deposit contract address. This is something that we can get into later. And then also we need to design a series of acceptance tests for 6110. So what acceptance test is a series of API calls to the execution clients. And then for each API call, we check on the response and see if everything goes well. So for example, maybe there is a fork choice updated. And after that, you prepare a payload with deposits in it there, and then you get the payload, and then you check on each, API call and see the response matches your expectation. Yeah, so the deposit structure is pretty straightforward. Yeah, so deposit, it has the public key, the withdrawal credentials, amount, signature, and index. On the execution layer side, these fields don't really matter to the client. It's just simply a placeholder for bytes. Yeah, but maybe one thing to note is that the public key here is BLS because it's originated from the CL side. But BLS, was never used on the EL side. So this is a little confusing, but, nonetheless, it's just, a name, that just holds some bytes. Yeah, so the changes here in the block header and the block body is very similar to, the withdrawals in the Shanghai upgrade. So we have, as opposed to withdrawals routes, we have deposits routes in the block header. And then we have, as opposed to withdrawals, we have deposits in the block body. The deposit routes is the root hash of the Merkle tree on the list of deposits in the block body. Maybe one thing that's worth pointing out is because 6110 is based on 4844. So you can see in the block header, the deposits routes should come after excess data gas, which is a field from the 4844. And also, yeah, obviously in the block body, deposits should come after withdrawals. Block creator. So the role for the block creator here is, so first off, it needs to extract a list of deposits from the receipt logs, and then, it calculates the deposit routes, and then, stuff the deposit routes in the header, and then the deposits into the body. Because the receipts logs, they are API encoded. So we need to have some sort of mechanism to decode the API to extract the deposits from their logs, which is completely foreign in the EL world because API usually it's a CL thing. Deposit extraction from the logs, they are order sensitive because you have multiple receipts, right? And then each receipt has multiple logs. So it should follow the order strictly. So I drew a simple illustration on the right side to illustrate. So you maybe in this case, you have 2 receipts, and then you have log 1 through 3 inside the receipt 1, and then 4 through 6 inside receipt 2. And not necessarily every log is a deposit. Some of them may not be deposits. And then at the end, the extraction should follow the order 1, 3, and as a list of deposits. The way we determine a log is a deposit or not is based on, we check on the address and see if it's equal to the deposit contract address. For the validation, it's very similar to the block creation. So pretty much it just extracts, again, a bunch of deposits from the receipt, and comparing it against a list of deposits inside the body. And as I mentioned in the previous slide, because the order strictly matters, so like when it compares, it should be like 1-to-1 in the exact same order. Yeah, so the Genesis config, because like in the block creation and the block validation, when extracting logs from the receipts, it needs to have like a deposit contour address to determine whether a log is a deposit or not. Even though on the mainnet, the deposit contour address like this address, it's not always the case in DevNets or some other private network. So we need to have this configurable. In the case that when the 6110 is activated and maybe some sort of user error, they didn't supply the deposit contour address in the Genesis config, 3 things should happen. Like one is when you do the block creation, there will not be any deposits inside the block body. And then the deposit root should be like the hash root of the empty tree. And then the block validation should automatically fail because when the validator extracts like a list of deposit from the receipts, it shouldn't get anything. And then when it compares nothing to something, it should fail. Yeah, so this is the current state and also like, things to do in the future on the EL side. So defining the deposit structure is done. All the appropriate changes to the engine APIs are done. Log creation, validation, and also the Genesis configs, they're all done. By being done, I mean they are all under the experimental features inside the main branch on Besu. So anyone can pull the code and just turn on the experimental flag, and these features should be activated. Few things to do is the acceptance test. So we are able to prepare payload with empty deposits and successfully get them. In the case that we want like a valid deposits, we are still working on it just because it's quite hard to make up some deposits. Not only deposits, but also like you need to make up the corresponding logs in the receipts. So this is something we still need to work on. And also currently Besu is not 4.4.4 ready. So all these changes implemented, they are based on pre-4.4.4. So once the 4.4.4 is implemented on Besu, we will rebase all our current changes to 4.4.4. Yeah, that should be all.
Yeah, all right. I want to talk about the specs on the consensus layer side. So I decided to do the implementation in Lighthouse because I have some prior experience with it. And in terms of containers, we have one new container called deposit receipt, and 3 containers that have been extended: the execution payload header, and the beacon state. The new deposit receipt container is essentially the deposit data container with an additional index field. And this index field is necessary for the deposit processing flow on the consensus layer side. In the execution payload, a new field called deposit receipts has been added. The execution payload header has also been extended with a new field called deposit receipts root. And for the beacon state, we have added a new field called deposit receipts start index. And this is used to keep track of where we are in processing the deposits. All right, so let's move on to the next slide, how block processing was affected. So we have made modifications to the process operations function. A check has been introduced which involves the deposit receipt start index field. And this checks determines when the former deposit mechanism should be disabled. And this is critical to ensure that all prior deposits are processed in order to avoid any conflicts between the old process deposit and the new process deposit receipt function. So the process deposit receipt function essentially performs 2 tasks. It first initializes the deposit receipt start index in the beacon state, and second, it applies the deposits. And to achieve this, apply deposit function is reused, as it is already implemented in the consensus clients. And that are like the biggest changes on the CL side. I also want to talk a little bit about how we tested our implementation. First, we focused on setting up a local DevNet. For this, we used a tool called Cortosis, and Cortosis is excellent for quickly setting up local DevNets, and it's really straightforward. And we quickly decided to move onto a multi-client DevNet. So for this phase, we needed tools to help us deploy, destroy, and swiftly redeploy DevNets. And the same setup is being used for ongoing testing for EIP-4844 as well. We received a lot of help from Paritosh from the EF DevOps team. He introduced us to kurtosis, created custom tools for our multi-client DevNet, and helped us a lot with debugging. So without his support, this wouldn't be possible at all. So next, I want to talk about the current status of the implementation. First, the fork to EIP-6110 is successful. So the genesis of the DevNet is the merge. Then we fork to Capella 4844 and then to 6110. And all forks are working smoothly. Also, deposits are being processed as expected. So as you can see on the right side, this is an actual output from our DevNet from last week. So which shows that the deposit receipts. As you can see, it contains the fields I've just mentioned earlier. So, however, we also have some items that are currently work in progress. For example, we are in the process of turning off the ETH1 data poll. And in the final part, I'd like to discuss the challenges we encountered during the implementation and testing. So first, understanding the code base was obviously a challenge. So we had to dig deep into the code to understand how forks are added and when they actually happen. Second, we encountered peering issues, especially during the transition when forking to EIP-6110. And debugging this issue was quite difficult. So we realized that debugging can sometimes be a straightforward process, but there are also some instances where nothing seems to be really out of place, even in the logs. So it's really difficult to pinpoint the exact issue sometimes. And third, navigating through the versioning of execution payloads was a little bit challenging. So we introduced a new version, v6110, and understanding how these versions interacted was not trivial. And lastly, the biggest challenge was harmonizing and ensuring compatibility for the versions of Besu and Lighthouse with respect to EIP-4844. So as 4844 is still a work in progress, finding the right versions that are both compatible and up to date was tough. And this added another layer of complexity to our process. But ultimately, this effort was worth it to ensure that our prototype is as close as possible to what we are aiming for in the final output. Yeah, thanks for having us. It's been nice to have this opportunity to share with you how we envision the deposit process in the future. I also hope that this talk has given you some insights into efficient ways to test client changes, while also highlighting some of the challenges you might encounter along the way. And if there are any questions left, we are happy to answer them.
Thanks, guys. Before going to questions, I would like to say special thanks to Besu and Lighthouse teams who supported us in the development of that prototype, and the Ethereum Foundation, who has given a grant to fund this prototype development. That would be not possible without their support. So let's move to the questions.
Right. Great overview of the present process and explaining the proposed changes. I'm excited to follow the implementation progress and the acceptance tests and the challenges that you have shared during the implementations were great. I mean, it is always mind-blowing to see how proposals, those are coming up, are free-flowing on both EL and CL. Thank you all for sharing this. For the next section, the Q&A section, I see here in the chat, we do have some questions. The first one is from Gajendra Singh. If you would like to go ahead and ask your question, please.
Yeah, I think it's amazing that CLs won't need the data polling and basically replace polling by straightforward consensus. So, but my question is that how do you think that this will complicate things for the CL client, especially when there is forking going around?
So the current ETH1 data pool is reorg resilient, as I mentioned, right? But the new one with this instant deposit processing is not that resilient to reorgs. This is because the deposit sequence in one fork, in one branch of a block tree, can be different to the other branch, and means that according to the existing proposal, basically consensus layer clients will have to handle this. As far as I know, there is the pop key to validator index cache that consensus layer client utilizes to get faster lookups of indexes by the pop key. And in case this proposal takes into effect, the consensus layer client will have to handle this complexity and will have to track if there were some changes in the pub key index matching depending on the fork. So some part of this cache becomes really tied to a fork. The fortunate part is that the main cache that has been the main portion of this cache, entries that has been already finalized will not change, but some tiny bit of the entries of this cache, needs to be dependent on the fork, on the block tree branch at where we are. So that's, there is a cost of such complexity, introducing such complexity to this proposal.
People will need to wait for their deposits to be finalized before basically picking up their validator index.
Yes, basically, yes. I mean, like, if people want to be sure that this index will never change, I mean, like, will not change, the matching between pub key and the index will not change. They will have to wait for finality, or when this whether gets finalized.
On the EL side, is there a queue system? Because I mean, I can imagine that, there could be a lot more deposits that can happen in a particular block, and would the same number of deposits are being included on the CL side, or is there a limit? So how does this thing works?
Yeah, this brings us to this slide, and the limit on a number of deposits after this proposal takes into effect, as it is currently designed, is basically the only factor that limits the number of deposits is the size of a block. I don't know if Peter Davis want to speak more about this, because he did this analysis on the number of
I'm very
deposits.
happy to say a few words. The limit is entirely based on the gas limit. There are, like, where you get down to it, like, really quite fundamental limits. There's, like, even no matter what happens, it's really unlikely that the cost of making a deposit is going to fall below about 15k gas, because the work that actually occurs in the deposit contract. You have to be a bit careful here, because the naive thing is to look at the cost of making an individual deposit in a single transaction. And that's quite expensive because there's a lot of overhead. But if you make a single transaction that sends a very large number of deposits, you get quite a lot of economies of scale. There's a lots of things that you only have to pay for once. Things like cold storage reads, things like the 21k gas that you have to pay to send a transaction in the first place. But once you do the analysis, you come to the conclusion that there's this, like, hard cap. And so we can be confident. And by the way, we should, like, expect people currently do send transaction deposits in, like, big batches, reasonably large batches of, like, several hundred anyway, just because they want to save this gas. So you just have to make sure that the consensus there can cope with. I mean, theoretically, it's possible that in the future we could get up to 2,000 deposits or slightly less than that, but that's the sort of level. And I think the conclusion is we're just going to have to optimize the consensus layer clients to be able to support that.
So essentially, EL clients won't have to implement any queue.
No, there's no queue at all. There's no queue on the EL layer, and, like, the consensus require clients don't have a queue either. They're required to just, like, they're required to validate all the deposits in the block they appear, which is different from the current situation, hence this analysis.
Okay, another question that I have is that, so deposit on EL side, when they will form the deposit, it's gonna be an SSZ container, right? SSZ encoded deposit.
You mean this new
deposit receipts that EL will give back to CL?
Yeah, so see. No, it's currently RLP encoded as per the EIP, and we'll see what other SSZ fine efforts will be finished with. I mean, if we turn withdrawals, for instance, if we turn them into the SSZ hash tree route, right? So we can switch deposit route as well to this new schema. And but basically Engine API exposes them as JSON, so that's the same as it is today with withdrawals and other portions of data. Like withdrawals, as a better example, because transactions are packed blobs of bytes for CL. So SSZ, we're open to change this part, but we'll see what will happen with the proposal on withdrawals, for instance.
Yeah, I asked this because we recently, kicked out SSZ from EL on 4844. So basically this would reintroduce SSZ. And I'm not sure what is the plan to get SSZ altogether into the EL side.
As far as I understand, it's just, it's yet an open question.
That's all from me.
Thank you so much, Gajendra Singh. I see another hand raised by Lion. Please go ahead with your question.
Great presentation. So I've been following the design of this feature since the beginning, and the original PR included the queue instead of the current design. So I think for me and others, could you recap a bit the rationale of why the queue was dropped for the current queueless design?
That's basically because there is a complexity of maintaining the queue, and there is a way of getting rid of this queue with a couple of implications. One is the complexity of maintaining the pubkey index cache that we have discussed. The other one is since there is no queue, we can't rate limit deposits processed per epoch, and this parameter is kind of important for the weak subjectivity period computation. But our analysis shows that if we move the number of deposits that can be submitted today to the number that can be submitted after 6110, considering this analysis made by Peter, it will not change the weak subjectivity period significantly. So that's why. So there is a trade-off, a bit of complexity on the caching side and maintaining the queue versus maintaining the queue in the beacon state. So yeah. And the current proposal decides in favor of this cache complexity. Probably if we see other proposals emerging that require the deposit queue for some other purposes, we can combine the two and switch back to the queue approach.
Thank you.
Thank you. So my next question is also with respect to the change when deployed with the upgrade. In the presentation, there was a mention of a cap. Perhaps the maximum expected time is 15 hours at the time when this proposal will be deployed on the mainnet. My question here is about the effect on users' transaction. We understand that validators' deposit would be affected, but would there be any effect to user transaction, or is it just a system level operation not affecting anyone?
It won't affect users. There will be a slight increase, I guess. There will be a slight increased computation complexity on the client side because we will have two deposit flows working, being processed together. But considering that there is on average less than two deposits per block, or kind of one deposit per block, this complexity should not be that high. So this transition period will not affect users. I don't think it will affect the system either.
Awesome. My next question is with respect to the proposal, which is currently helping out with the exchange of information on the interface level. So the proposal 6110, it mentions that it will eliminate the requirement to maintain and distribute deposit contract snapshots, which, if I understand correctly, is currently being taken care with the EIP 4881. 4881 is currently in the review status. I'm curious to understand the current status of implementation of 4881 plus, or do we need it even if 6110 is deployed?
We would not need, if 6110 is deployed, we would not need the snapshots anymore to bootstrap a node. I don't know what's the exact status of this EIP. Maybe other people on the call can help with that. But I know that I've heard that, and probably this is the implementations of this EIP. Some clients already maintain the snapshots of deposit contract to bootstrap a node faster than it would be to obtain all logs from the execution layer client. So this, as far as I know, and this EIP is not a core EIP,
no,
as far as I understand. Yeah, so it's a complementary thing that clients does not hardly depend on. So it's really improves UX and improves the node bootstrapping process.
Right. Yeah, that is an interface proposal. So I was curious to understand how we are working right now and if we have implemented it in all clients. Nevertheless, that is a question for the authors of that particular proposal. I hope that we have this conversation sometime with co-authors and get this answers. My next question is with respect to the deploying of the proposal. When on the mainnet, when do we see this proposal? I'm assuming this is not coming up with the Denkun upgrade. Or do we have any timeline in mind?
Yeah, sure. So it's not coming into Denkun because it's moderately big, but still big feature. And Denkun is was quite packed already by the time that we have discussed this proposal. And this proposal is roughly planned for the hard fork next to Denkun. And if we will keep the same cadence of delivering forks on mainnet, we can assume it's not yet decided at all. We can assume that Denkun, for instance, happens this fall, and in like Q3 or Q4 this year. Then we have the next fork happening in Q2 next year, and this is probably when this proposal comes to the mainnet. Yeah, but it should be taken with a grain of salt. I mean, like, it has not planned at all. So that's just my personal rough estimation on the timeline.
That makes sense. Well, thank you for sharing that. And I saw in the presentation there were some things to do. I assume we will have enough time to have them completed and be tested. So that's fair estimation.
Yeah, we're working on that.
Very well. We are close to an hour mark. I'll be curious to hear your thoughts on EIP process, especially on the consensus layer EIP. And my question is also directed towards the discussion placeholder. I find the discussion to link is pretty much empty, but I'm assuming there are a lot of discussion going on with respect to this proposal. So where is that actually taking place and how people can follow it?
I think a portion of discussion around this EIP happened during one of the R&D meetups, where in person with among client developers and Ethereum researchers. It was very fruitful discussion, and the thread is empty indeed, but there is no other threads that discuss the EIP a lot. I mean, so this remains the one thread where should the discussion points to be raised regarding that EIP. And with respect to the EIP process, recently I've added the consensus layer specification to the EIP. So the EIP originally it was just the execution layer specification outlined in the EIP document, and I think it makes a lot of sense because it gives a holistic view, and we can include the consideration. This EIP has a lot of security considerations on the consensus layer side, and having this consensus layer and execution layer in one place under the hood of one document makes it possible to include all the security consideration just in one place, which is great. That's kind of a new thing, the EIP process, and I really like it, enjoying it. Maybe Kevin and Navie has some thoughts and has something to share on how to work with the specs and how to implement them. I know you guys want to speak up.
Well, personally, I found the specification to be, pretty straightforward on the execution layer side. And, on the EIP, there's some pseudocode in terms of like how you extract the and also like the way you validate stuff. So I think that's pretty easy to understand. It's pretty straightforward. So
right.
Yeah, I can agree with what Navie just said. It's not that complicated. Yeah,
that's good to know. We generally try to keep a placeholder for discussion because I'm assuming because this proposal is affecting both layers and also kind of hit the mindset of people who are new trying to join as a validator may come up with some questions. So it's a good idea to keep this placeholder open. We should expect some upcoming questions or discussion on Fellowship of Ethereum Magician as linked in the proposal. I think I had a few more questions I wanted to go over, but in the essence of time, let me open this platform for all of you to share your word of advice or that you would like to communicate to the Ethereum community.
I would say join Ethereum for protocol development, participate in the Ethereum Protocol Fellowship Program. This is a great opportunity. I really enjoyed to work with Kevin and NC on this prototype.
Yeah, if you have the opportunity, then definitely join the EPF. It's worth it. It's currently starting, I think, in about 1 month or something. And it's permissionless, so you don't have to be accepted. You can just join and contribute.
And I also think like the list of projects. So like now they're open up cohort 4 and I was from cohort 3. And it seems like the list of projects on cohort 4 is even bigger than cohort 3. So there are just more and more projects desperately need people to work on.
Absolutely.
Yeah. I also want to add that Ethereum client developers are open to help and facilitate any feature development with their clients, even considering they're really quite busy with their day-to-day responsibilities, yeah, there is a huge willingness to assist on every contribution to the client. So it's quite easy from that part as well to chime in to their core development.
Absolutely. Thank you so much for this. I suppose this is exciting to follow EIP-6110 that is proposing a significant increase in deposit security by simplifying the process. Kevin, Navie, Mikhail, Peter, we thank you all for joining us on PEEPanEIP and sharing the proposed changes. I appreciate you taking out to share valuable information with us. On this note, thank you to all our YouTube viewers for watching and podcast subscribers for listening to this special episode. Should you have any question on this and any other topic, let us know at ETHCat Discord. Next week, we will be back with another interesting talk. Till then, keep watching, keep listening, and keep sharing your love with Ethereum cat holders. Cheers.